Okay, good morning, ladies and gentlemen. This is Kyle Olson. I'm with Eaglelift Incorporated, and today I'm going to be presenting to you the Reclaiming Aged Infrastructure, a Trenchless Revolution presentation. This is being presented by Eaglelift Incorporated. That's who I've been working for the past 10 years in the engineering department, and this presentation is going to be PDH approved, so you can get certificates for continued education hours, or professional development hours, depending on which state you're in. This webinar is scheduled to be about 1 hour long. During the presentation, you guys' microphones will be muted. It actually started a couple minutes ago. But if you do have questions, then if you look at the toolbar on the what should be right-hand side of your screen, there's going to be an area here that you will be able to type in messages, questions, comments, other types of communication. Go ahead and click this questions tab, and that will get you over to being able to ask questions. We're going to have a Q&A session after we're done giving the presentation. Hopefully 15, 20 minutes we'll be able to answer any questions you guys have, but until then you will be in mute mode and the questions are going to be held off until the end. After the webinar is finished, you will receive a follow-up email that will provide a link to a questionnaire form. At that time, you guys can ask us if you need a certificate for your PDH hours or anything else of that nature. Also, you're going to get an email that has some video links to some of the information that we're sharing. Pictures are worth 1,000 words, but the videos are truly something incredible. This video doesn't stream super well when we're giving presentations like this. Anyway, without further ado, I'm going to talk to you a little bit about Eaglelift Incorporated and why we are qualified to give a presentation like this. Eaglelift was established in 1995, actually incorporated in 1995 as a Class A general engineering contractor. We operate out of California, Arizona, and Nevada, where we do work with a multitude of clients, which we'll talk about in a moment. We're certified small business and DVBE certified as well, with 37 employees and 2 engineers, including the president and vice president of the company. We have operating headquarters in Rancho Cucamonga in Hayward, California, as well as a satellite location in Las Vegas, Nevada. What Eaglelift does is foundation lifting and stabilization using helical piers, push piers, basically any steel underpinning type system, as well as URETEK chemical grout, which we'll be discussing today for shallow surface stabilization and densification, rail ballasts, roadways, again, multitude of clients. Eaglelift also provides geotechnical engineering services such as site assessments and facilitating geotechnical analyses if you guys have an existing soils report, and we sort of bounce ideas back and forth on how to put a repair together and how to design that. Other type of work that Eaglelift performs is sewer rehabilitation, both sanitary and storm sewer sealing and encapsulation, manholes, lateral line realignment, infiltration and inflow mitigation. The clientele that Eaglelift works with has various different industries, from commercial clients, industrial clients, could be schools, warehouses, distribution facilities, public works departments, which we'll be focusing on today for our infrastructure, but manholes, roadways, highways, transportation, residential clients, and government clients as well. So we kind of have a wide variety of clients. A little bit about what we're going to talk about is URETEK deep injection process and the URETEK method. This is a form of compaction grouting that utilizes a structural polyurethane. And what this is used for is specifically what we're talking about here with infrastructure management. When you guys have a leaking culvert or a failing manhole or something that's creating roadways and highways to begin settling, which could be rainwater, cracks in the asphalt, you know, a rise in excavation costs over the past several years has made it almost impractical to both R&R or just sort of pave over. You put a Band-Aid on a broken arm, it's going to fail pretty quickly. So the real repair would be to completely demo everything out and then install brand new concrete asphalt, or especially when you're talking about manholes and culverts where we're not talking about just digging out a section of road. Now we're talking about digging, excavation, trenching, shoring, pulling all of those spoils out, fixing the problem, which could be the manhole or the culverts, and then importing dirt back in or using an engineered fill, densifying everything, laying new ones. So a lot of downtime. And as time moves on, all of the excavation costs and costs for disposing of spoils are continuing to increase. So what we look at is methodologies to buy more life out of our aged infrastructure. If you were to do a whole new repair that cost $180,000 for a super small section of road, shuts the road down for 1 month, or at a distribution facility where trucks drive over regularly and it's creating a failure, you don't really have the option to shut that down for 2 months. So how do you buy more life out of the infrastructure that exists? And that's a lot of what we're talking about with the compaction grouting and permeation grouting. One of the best methods of permeation grouting for leak sealing as well as densification and lifting operations utilizes the structural polymers. So the URETEK deep injection process as well as the URETEK method addresses these two issues, this form of compaction grouting using a structural polymer as compared to a cementitious grout. Most people are familiar with mud jacking or pressure grouting, which has been around for 80+ years. Structural polyurethane is sort of the next big thing, the next update, the next technological advancement moving forward in the field of compaction grouting. So what is URETEK? I said URETEK deep injection and URETEK method. URETEK is a company name. They are the developer of utilizing high-density structural polyurethane for pavement lifting, soil stabilization at depth, subsurface soil compaction, and water displacement and containment. Now, all of these different processes that I just discussed utilize the same proprietary multi-component chemical resin, or structural polyurethane. They're a worldwide patent holder of the URETEK deep injection process, which is done for deep soil stabilization and densification. And Eaglelift happens to be the sole license holder and applicator in the states of California, Nevada, and Arizona, which is why Eaglelift is often represented as the URETEK Southwest dealer. The URETEK polymers, or polyurethane, allow for flexible use for lifting, sealing, void filling, and soil compaction operations. Once injected, the polymers expand up to 20 times the initial liquid volume, which means they're injected under a very low pressure. If they're being injected at depth through a pipe, oftentimes it's just enough pressure to push the liquid of the isocyanate in the resin through the tubes and into the soil. As a liquid, it is introduced into the soil and then permeates through the soil or lensifies down into the soil, and then the chemical reaction occurs, which expands the polyurethane, and depending on the type of soil, it will either bind the soil together to create a very solid substance, or it will push against the soil, which gives us the densification that we're looking for. Now, the more sandy a soil is, the more silty, the more polymer it'll take in order to achieve the goal. However, the more sandy it is, the more it binds the soil together. When you start getting into clays, dense, medium dense clays, and so on and so forth, that's where it starts pushing against the soil and displacing the soil. Or on that note, however, one of the limitations of using any structural polyurethane in soil is when you get into your caliche clays or your Libby Gulch clays or your fatty clay, just really dense clays. By application, we're discussing about injecting under a low pressure. This requires the soil to be semi-permeable. If the soil is already as strong as concrete, then there's really no reason to be doing a compaction operation or a densification operation, and the polymers have difficulty permeating through that soil. Another advantage to using a structural polyurethane is that it's environmentally inert. It has just about zero impact to groundwater. Now, I can't say it has absolutely no impact because it is a hydro-insensitive closed cell polymer, which means it won't bind with water or bond or be attracted to water like some polyurethanes are. Instead, it will displace water or push against the water. By this method, when you're doing sealing operations specifically, or even a better example is when you're injecting directly underneath a freeway in order to void fill in a line. Oftentimes, if you're standing on the side of that freeway, you're watching water just shoot out the side of the freeway, and that's because it's being pushed. By that method, you're effectively void filling and lifting the freeway, and you're also creating sort of a barrier for water not to permeate through. Structural polyurethanes are highly controllable and structurally stable. We'll get into the structurally stable part in a little bit, but I wanted to touch up on highly controllable. There's a lot of companies out there that are beginning to do polyurethane injection. Like I said, this is the next big thing, and as the word is getting out, other companies are jumping onto this opportunity to utilize a structural polyurethane over a cementitious grout based off of its benefits. Experience speaks 1,000 words also. We've been doing this for a little over 25 years. URETEK has been around for a little over 35 years. And it's very possible to create overlift or to overseal and create a lot of damage in doing that. So when you guys plan on utilizing a contractor in order to do the void filling, sealing operations, just make sure they know what they're doing. And in the picture there on the right, you can see an example of a solid monolith of the polymers and soil aggregate once it's all set in place. This means they built this plexiglass box and put soil inside, then shot the polyurethane and removed the barrier on the outside, and that's sort of what you see afterward. Everything's bound together. The URETEK deep injection process is a patented 3-step application process. There's a subsurface application into the problem zone via direct injection tubes. This means if the problem is 15 feet down, where you've either done dynamic cone penetration testing or standard penetration testing, you just found super weak layers of soil 15 feet down, one of the advantages of URETEK is that they can drive injection tubes down to 15 feet and perform an injection at that level. Surface level injections are great. They solve the symptoms of the problem, such as leveling a slab out. But if the problem exists deeper into the soil, you need to solve that problem deeper in the soil. Otherwise, it'll just come back. So that's why we utilize the deep injection process. Again, it uses the same proprietary 2-part expanding structural geotechnical polymer, and it's constantly constantly monitored by using either a laser, zip level, or more conventional levels. Oftentimes with slabs, you'll see a dial gauge being used out there. The composition of the URETEK polymer is that it's a resin and a hardener. From the iso to the resin, you have a 1-to-1 mixing ratio. And it creates an exothermic chemical reaction which generates CO2 gas, and that gas causes the expansion of the material. This creates the lifting pressure or the lifting strength. Strength can be up to about 5 tons per square foot, I believe. It's a very fast reaction time, and it can be adjustable. You can actually speed up the reaction time or retard the reaction time based off of the temperature of injection or the type of polymer that's being injected, because it can be a very aggressive polymer designed to create a fast lift, or it can be a non-aggressive polymer which is designed to permeate further, and that's more for your sealing and stabilization projects. Once more, it's environmentally neutral. We actually have our NSF 61, which means the polymers can be injected on, near, in, or around potable water. I don't recommend drinking the stuff. However, it is perfectly safe for you once the reaction's occurred. It has a rapid cure that can support loads after 15 minutes. As a matter of fact, it reaches about 90% of its total yield compressive strength within those first 15 minutes. After about 24 hours, it's ready for a full load and it's reached full strength. This is important because of what I was talking about regarding downtime. If you shut a roadway down in order to R&R and pull out a manhole, completely put a new one in, densify, pour new concrete, and so on and so forth, you've got literally months of downtime, several weeks of downtime. as compared to doing a polyurethane project, or this is really any compaction grouting project, unless you're using a cementitious grout or cement slurry, because the cure happens so fast. When you use a structural polyurethane, by the time the operating crew finishes packing up and taking off, you're ready to take down your traffic control and reopen up the roadways or distribution facilities or whatever it is you happen to be injecting under. It's one of the major benefits of using the structural polyurethane over a cementitious grout for compaction grouting operations. Again, it gets very, very strong, and although it gets very strong, it's very lightweight. Cementitious grouting will weigh anywhere between 120 to 145 pounds per cubic foot, versus the polyurethane injections, which generally weigh between 4 and 25 pounds per cubic foot. This is weight of the product after installation. Once more, it's hydro-insensitive, so it makes it very, very good products for leak sealing and water displacement. Again, I keep talking about cementitious grouting, cement sand slurries, and different things like that because compaction grouting using a cementitious grout has been popular for over 80 years. Excuse me. The difference in advantages for disadvantages, both of them have advantages versus disadvantages, but why we lean more toward the structural polyurethane is for reasons like the application hole sizes. If you use a cementitious grout, you're looking at 2.5 inches or more size diameter holes versus URETEK's 5/8 of an inch, which is only about the size of a penny. This is important not only cosmetically but also structurally, because we're not making Swiss cheese out of concrete slabs. Concrete has a tendency to mix with water. Polyurethane pushes it out. Cementitious grout is variable. URETEK oftentimes will hit 60 plus psi. Lifting accuracy for grouting, traditional grouting, is 1/2 inch, and URETEK is accurate within 1/4 inch. Once again, the weight issue, the environmental issue, and the cure time. It's time and again it proves structural polymers are sort of the new way that we're moving forward into the compaction grouting age. Once again, the deep injection process is in situ stabilization of soils at depth. So when you're thinking about injection, an injection project and what the layout is going to be, we think 4 to 5 foot grid patterns on the XY axis because you've got 8 to 10 foot diameter sphere of influence, so you get a little overlay. Now if you take that same grid pattern and you put it on a Z axis, now you've got a little bit of overlap on that same 4 to 5 foot grid pattern, but you're creating essentially very strong, stable columns of soil beneath whatever is on the top level. This could be buildings, freeways, bridge approaches. It could be absolutely anything, even up to manholes. So by creating sort of that strong, stable column, you're supporting whatever happens to be on top and extending the life of that infrastructure with zero excavation. When you do these multiple depth injections, you start with the lower strata to help anchor the upper strata, increases the densification potential. The polymers get stronger the more confining pressure you have, so you start by creating a strong base and then inject in the middle to get better densification and increased potential for lift. The method itself is directly under slab injections. This is used to stabilize the structure utilizing the same horizontal XY axis patterns. But the primary use is for void filling, slab lifting, and undersealing. Again, this is the surface level, not injected at depth. The gridded patterns help to ensure the material addresses the affected area, and it's consistent with material distribution and highly improved weight-bearing capacity. What we mean there is if you have a section of roadway or if you get rocking slabs inside a warehouse that every time a forklift drives over it rocks and it's beginning to crack and fail, by returning the connection or restoring the connection of the soil to the underside of that slab, the distribution or the distribution is more even across that slab, which improves the weight-bearing capacity of the slab throughout. So once again, we are buying more life out of the infrastructure that exists, and once again, it's without excavation. A primary example of that you can see on the right-hand side here, the before picture. You can see all the faulted joints. Now, there's a lot of different things that cause this, but this is one very common sign of settlement. In the after, before you look at the picture, you can see on the left-hand side in the diagram, polymers are injected at depth to strengthen the affected area of the soil, and then also injected directly through the concrete at the joints. This fills the voids that you can see in the top diagram with a structural polyurethane of 60+ psi, which you see in the bottom diagram. And by bridging that connection, you're restoring the strength of the slab and re-leveling. The re-leveling you can see in the after picture on the right-hand side. So if you could just use your imagination a little, 5/8" holes at each of the faulted joints, you're talking for 4, 5, 6, 7 of these joints that you see in the pictures, it's only a few hours of work being performed here versus ripping and repouring and all of the costs and potential downtime for whatever roadway, highway, or whatever it happens to be for ripping and repouring. Another great example is the concrete pavement systems use stabilization and lifting of dips and faulted joints. This includes concrete pavement systems that have a drainable base, which you can see here in the picture, the close-up of the faulted joints. This is actually rather severe settlement. And then after the injection of the structural polyurethanes, that gap has been closed. And you can see here, if you look real close on the after URETEK pictures, these white marks on the floor. Those white marks are the residue from drilling. It's the same grid pattern we're talking about, 4 to 5 foot levels, but the actual holes we inject through would only be the size of a penny in the middle of those white marks on the asphalt. So very, very, very little external damages and very minimal downtime in order to get very real results. I like this one more for the before and after, which you can see from the pictures. You've got a roller coaster of a roadway in that before picture. And from the diagram with the base dip, you can see it's almost the same thing as that faulted joint. You've got voids underneath the roadway, which decreases its ability to support weight, which creates that dip. So you do the same injections at depth, and you could do under street injections, although it's kind of tough on pliable surfaces like asphalt, and create a lift, and then you can see in the after pictures, everything is completely straight, running through and through. It's another clear-cut case of compaction grouting operations giving you zero excavation, otherwise known as the Trenchless revolution. Faulted joints, I think this is the before and after drawings of the same presentation a while ago. I apologize. But the point is that you don't want to inject the drainable base specifically, because polymers will actually fill any drainage you have running through there, and it won't be drainable anymore. And it'll also cost a lot more in polymer because you would use a lot more product in order to fill the drainable base itself. So you inject directly underneath that base, and you try to push that base up using the deep injections to push the soil. There was a project done with GPR technology. It was a test, I suppose, an experiment where we used GPR on a freeway, and the polymers did not show up on the GPR, just kind of shot straight through them. So what we, GPR being ground penetrating radar. So what we wound up having to do for the test is this exact concept that we're looking at here. Perform deeper injections in order to push the soil up, and then it would register with the GPR that those voids had been filled with a product or a substance. There's a very, very high, very diverse application of compaction grouting technologies. So I wanted to go over a couple of different case studies, projects that have been done with the structural polyurethane to sort of see not just we did this and it was great, but also the various different applications for infrastructure repair and rehabilitation. In January of 2013, URETEK Holdings performed 290 lineal feet of an in-situ grout wall. They injected URETEK's 486 star geopolymer for Florida Department of Transportation. Again, it was a hydro-insensitive 2-part polymer that was injected in a highly controlled manner through 5/8" holes and 1/2" diameter steel injection rods. After Hydra Lansing, or water jetting to clear utilities to 5 feet below the land surface, the injection rods were installed at 5 discrete elevations in a 3-foot horizontal and vertical grid pattern. The material was then injected through each rod, which expanded to at least 15 times its liquid volume, which formed a sort of sphere at each location. They performed 490 injections total at 58 points along 290 lineal feet of the SR5 or the US1. This created a hydraulic barrier that restricted the groundwater movement from a contaminated site to a construction site where drainage failures were being installed by drainage features were being installed by FDOT. This removed delays to the project as construction dewatering would have been impacted by the contamination. So the Florida DOT team received a Prudential Davis Productivity Award for this project for utilizing an innovative process to minimize contaminated impacts to their construction site. This is a picture of a manhole that was done in Clarksville, Indiana. TV inspections showed large amounts of inflow and infiltration in 7 different manholes. Because of the hydro-insensitivity of the polymer, again, it makes a phenomenal leak sealant. So you can see where the faulted joints in the before and after picture had water infiltrating into each of the manholes. They had brick manholes, steel manholes, et cetera, et cetera, et cetera. And by performing the void filling operation specifically and deep injections also in order to densify the manholes and prevent further movement, they were able to effectively seal the manhole, which you can see in each of the after pictures is a little bit of polymer that was infiltrating to the inside during the injection and actually sealed the leaks while they were injecting, which means the water was actually coming into the manhole and then it stopped coming through and a little bit of polymer actually permeated into that manhole at the time. All of the work for the 7 different manholes was completed in a day and a half. They stopped the high pressure leaks in minutes and significantly reduced flowing through the sanitary system. And they saved the city over $90,000 per month. And I'm just going to throw that out there again. They saved the city over $90,000 per month by sealing these manholes. Since the repair, 49 pump hours per week has been reduced down to 17. The cost savings of $100,000 per month since the repair. And this is still going on. And I believe they have a great case study that was built on this project, and there's even a couple of references that they were able to pull out of it. Transportation services, we've been talking a lot about roadways, manholes, different things like that. The services would be slab leveling and stabilization, soil stabilization and void fill, mitigating groundwater migration, and infrastructure rehabilitation. There's various different applications for the transportation department, which includes roadways, bridge abutments, MSC wall stabilization, runway leveling, rail ballast stabilization, ports, bulkhead and seawall repair, sewer rehabilitation. The project was done for Caltrans, California Department of Transportation in Irvine, California, where 1/2 to 3 inches of settlement of 4 bridge abutments and departures happened in the toll roads, causing dips in the roadway. Now this was kind of a point of contention because the toll roads in this area were brand new. And then they are experiencing over 3 inches of settlement. Heavy, heavy traffic required traffic control on the 3-lane highways passing through this area, because those toll roads were originally built to mitigate the traffic off of the 91 freeway, which is an adjacent freeway through the Irvine area. Utilizing the URETEK deep injection process to densify the soil, increase the weight-bearing capacity, and lift the pavement to grade, we were able to work with Caltrans for developing a traffic control plan and work as the GC. They reduced operational impact by mitigating the need to replace the pavement. They leveled the pavement by bringing it back to grade and fully restored the use, and they were able to work at nighttime. In order to avoid the high traffic volumes, they were actually able to shut down the lanes without impacting the traffic negatively. And it took 2 weeks in order to do all of the sections that was required, because it's not, this toll road is not a very small road running through and through. So it took about 2 weeks to complete the entire project, but they were able to pull down the lane closures at the end of every night and then start it up the next night. So once again, traffic was not negatively impacted. And they were able to save the client over half the cost of ripping and repouring. Doing this project cost literally 50% less than ripping and repouring all of those sections. Over the years of heavy use, the pavement, subbase, and base beneath the gantry crane wheel pass in the Port of Oakland had begun to subside. The subsidence is very common in situations like this, where cyclic loading and heavy loading conditions, especially when the loads have increased over years, impacts the base and subbase with high water tables, and especially in the ports. The differential settlement not only made it difficult for operators to align their cargo properly, but also created safety hazards while the cranes traveled along the site. The settlement ranged anywhere from ½ inch up to 4 inches at the worst cases. Prior to any injections taking place, some DCP tests, or dynamic cone penetration tests, measured the relative soil density, which indicated that the subbase needed to be densified at least 2.5 foot depth. The URETEK process was then utilized to densify the soils and then lift the pavement to grade. The 2-part polymers injected through ½ inch tubes, once again at your 5-foot grid pattern, which you can actually kind of see on the far right picture, directly underneath the wheel path for the gantry cranes. And the resulting mixture polymerized beneath the slab, creating minimal heat with optimum expansion. With the expansion, the material aggressively seeked out the voids while densifying the surrounding soils and lifted the pavement back to its original elevation. The project was done for BMP in Baltimore for Amtrak. Soft soils underneath the track were completely saturated with water, and as the water was saturated, as trains passed by, that water would literally pump onto the tracks, which you can see in that center picture, and the far left picture is a pretty good indicator of water as it stood at the bottom of the tracks as well. The result was that the rail had settled up to 1.5 inches. With limited work hours, each location had a very, very tight project window. But we were able to inject the URETEK polyurethane from the surface to dewater and stabilize the soils, and then lift the rail back to grade. The injection ports were at various locations and depths. Working with Amtrak, we were able to get minimal downtime because all of the work was performed within that small window we were discussing, to keep the downtime of the trains that passed through that area down to almost 0. The rail was lifted a full 1.5 inches up to grade, and as I was mentioning with the freeways earlier, when you're injecting, you can actually watch the water being pumped out while the injections are occurring. So during the injections here, you were able to see the water being pushed out, and since then, Amtrak has not experienced a problem of water infiltration or settlement in this area. Jackson Lakes had a box culvert in Pensacola, Florida. Intense rainfall and historic flooding occurred on April 29th, 2014. Due to that, J.L. Halstead conducted a preliminary damage assessment on 6/14. The National Weather Service reported 20 inches of rain over a 2-day period. The embankment failure of South Pond allowed Jackson Creek to flow under culverts, causing significant undermining and soil displacement from beneath the culvert. URETEK performed on-site testing and identified an average of a 2-foot void. That's not 2 feet down into the soil. It's a 2-foot void and settlement of plus or minus 2 feet across the southwest portion of the culverts. They injected over 38,500 pounds, and it was a surgical injection that was designed to lift, underseal, void fill, and restore structural stability to 1,675 square feet of a quadruple barrel culvert. 24 inches of lift was achieved on a 4-foot grid pattern of injections through the base of the culverts. Then the method, instead of deep injection, was used to underseal and ensure all those voids were filled. In a quote from J.L. Halstead, they said, "The local market recently has been exposed to a geopolymer soil stabilization and lifting technology. The technology is said to provide a means of structural lifting, foundation subsidence correction, and void filling. It would be prudent to explore this technology as a possible alternative to complete replacement of the concrete culvert." This is sort of an imagery that I like using when we're talking about manholes and culverts. You can see voids that exist next to the manhole. This could be due to cracking at the surface or failures inside the manhole itself. It creates very loose layers of soil, voids underneath any area that has a crack, and this can result in the downward movement of your manhole. So we'll actually drop people using an A-frame with, of course, confined space entry training and whatnot, into the manhole in order to perform lateral injections. And on these lateral lines that need to be protected so that we don't plug them with polymer, oftentimes they'll put a rubber bladder on the inside to prevent polymer infiltration into those lateral lines. They'll seal around the pipes first, seal around the manhole itself as well. Then, provided the manhole is in condition to be lifted, more injections are performed at the bottom of the manhole to create an upward pressure and lift the manholes back to level. Sewer infrastructure rehabilitation is another application of the URETEK product. It's the application and sealing of lateral lines in manholes utilizing the URETEK deep injection and method applications. Again, it is a trenchless application that can be applied from the surface or from within the pipe if over 36 inches in diameter. So what we're talking about is, like my last image showed you guys, what we're talking about is sealing all of the lateral lines, lifting to level, rehabilitating and refurbishing this entire manhole, and buying years and years of life out of it for a fraction of the cost of having to cut out the concrete, dig all the way down to the bottom, replace your manhole, re-put the engineered fill back in, proper compaction, and then laying concrete over the top. A popular problem that we've been seeing in local municipalities lately is that anytime you have an underground utility trench or lateral sewer line, they put the dirt or engineered fill back in, and then because they're afraid of damaging the utilities or the lateral lines, they never achieve proper compaction. And one of the big things we've been able to do is to come in and perform deep injections at the depth of the utility trenches or the lateral lines in order to seal and stabilize all of the soil and realign the roadways. This is a very, very popular problem lately, and you do that without shutting down the roadways, which is why it's so critically important. Because the polymer will travel and lensify through the path of least resistance, we never worry about injecting around concrete because it will most likely seal the concrete first and then push against the soil or bind with the soil surrounding. It's a picture of an application for soil stabilization and void fill. It's a manhole, brick manhole, which you're looking obviously down from the top. The structural realignment or stabilization, sealing or encapsulation of the sewer against infiltration and inflow, otherwise known as I&I. as well as preventative maintenance. For structures, it happens to be outfalls and dams, manholes, lateral lines and culverts, or lift stations. And it is very often that we're doing a void filling operation that you see polymer infiltration like that inside what you're injecting into. Another difference between polymer and cementitious grouting is that for this stuff, you just give it 20 or 30 seconds to solidify, and then you can break it off by hand. Very, very simple, clean cleanup process. Case in point was a manhole B8 brick stabilization in Knoxville, Tennessee. Lateral pipe had sheared and extensive voids and loose soil was around the manhole. We filled it at 25 feet below grade, sealed and stabilized around the manhole. And it's a great representation of how the polymers aggressively seek out and permeate through any existing voids. Operations were being done up in by URETEK, Canada, where a contracting company was installing a large diameter culvert along an industrial street approximately 25 feet below grade. During their excavations, they hit pocket voids, which caused a collapse of the soil, which actually got their excavator stuck underground 25 feet. So some testing was done at the surface, and they found where all of the loose soil and pocket voids were located. And URETEK was able to come in and perform multiple injections in order to densify and lock all of the soil into place. And after they were done, the company was able to back the excavator out and then move it forward again and drill straight through the polymer and the soil. So the polymer didn't get so strong that their excavator couldn't even break through it. So it was kind of a win-win-win-win situation for all of the companies that were involved. In Hayward, California, we did pipe joint sealing, and this is probably a phenomenal example of culvert manhole stabilization without having to trench. You can see in the far left, there was 140 lineal feet of 30-inch storm drains that was leaking at 90% of the joints, which resulted in subsidence of the roadway, sidewalk, and then all the way through the residential district that the culvert was storm drain was running underneath. The pipe ran through 3 different residential properties. Now, if you could wrap your head around the scope of needing to tear up somebody's driveway, their lawn, their sidewalk, they would not be able to park in their house, the safety hazards that would be existing if they continue to live in their house, and we even had one particularly difficult client who was complaining about needing to be relocated, and somebody would have to pay to relocate them because they didn't feel safe of the health and safety implications of all of this work going on in front of their house. So potentially going on in front of their house. So instead of digging everything up, a GPR scan was performed to locate the vertical and horizontal alignments of the pipe, and then the deep injection was performed at depth in order to seal, densify, and lift the pipe back to level. So each joint was successfully sealed as polymer infiltrated the entire length of each joint. They used a camera to watch this process happen, and then any excess polymer that did infiltrate into the pipe was actually removed upon completion. The pipe was totally rehabilitated in a single 10-hour shift. And that's why I like the pictures top left, top right. You can see we didn't have to dig through anything. Using the compaction grouting operation, it was a surgical incision and then injection down at depth that accomplished this entire project with 0 downtime, 0 relocation, 0 non-use of a driveway, and so on and so forth. The clients were happy, the residential homeowners were happy, everybody was happy at the end of this job. So it's a phenomenal example of trenchless technology, or trenchless revolution. Once again, Eaglelift does provide some engineering services. This is a review of soils reports, again, just sort of making a meeting of the minds. We're familiar with many different types of processes, but some of the things that we like to bring to the table is trenchless technology, and the applications where maybe compaction grouting is necessary or better than polyurethane, or more often than not, we recommend the structural polyurethanes for deep soil stabilization. As a general engineering contractor, we do work with an esteemed network of engineers. We have an array of different engineering services such as dynamic cone penetrometer or DCP testing. We perform soils testing or test piers if you plan on doing a steel underpinning type project for foundation retrofits or helical installations for pre-constructions. And we also handle a lot of the engineering and permitting processes for code compliance and coordination. We've got a long history of successful engineering and permitting, which I'm sure all of you engineers know working with municipalities is not always the easiest thing. We'd like you guys to connect with us. Feel free to look us up at facebook.com /Eaglelift Inc. We're also on LinkedIn and YouTube, where you can see a lot of our personal case studies. Also, if you guys look up URETEK, you can see a lot of the stuff that people are doing not only across the United States, but in different countries. URETEK was originally founded in Finland 35 years ago, so they're in about 35 different countries already. There's a lot of really cool, really interesting things going on. Once again, thank you. My name is Kyle Olson. My contact information is on this slide. And don't forget, you guys will be getting a follow-up email with a questionnaire to fill out regarding this presentation. And at that time, you can also request a certificate for your PDH hours. And at this time, I'd like to open it up to some of the questions that might be put through our question box.
All right, great. This is Robert Armstead of Eaglelift. If you do want to submit a question, again, just a remind, please go into the toolbar window of the GoToWebinar. You'll see in there a line down near the bottom called questions. If you hit the plus mark there, you can send a question via that area, and we'll be taking questions now. So I do have one question. The question says, how can you achieve lateral line sealing and also soil stabilization for an above roadway?
For an above roadway?
Yes.
Similar to that slide that I was showing, oftentimes for lateral line stabilization and leveling, we'll actually drop someone into the culvert first, or manhole, or whatever it is that we're trying to inject through. If GPR scanning is necessary to find the location of the lines at various depths, that's one of the things that we will also utilize. And then you perform deep injections at the level that those lines are located. Now, we've done this a lot next to residential homes where you have super sensitive things like that, but also like city of Clovis, city of Glendora, we've done it underneath roadways. Because the polymer travels the path of least resistance, we aren't ever worried about damaging utility trenches, manholes, storm drains, lateral lines, really anything unless you have that really, really old school brittle clay. If you've got the brittle clay, then more care needs to be taken in design. But again, because it travels path of least resistance, we perform injections at that level. If it's a large diameter, we go to the left and the right of it. We'll obviously go to the top of it. The infiltration will happen to the bottom of it. We will inject at that level in order to seal it. Oftentimes, if it's right next to a manhole, we'll put a rubber bladder in to ensure there's no polymer infiltration. And like we've done on many culverts underneath freeways, you can also put a camera inside the lateral line, a little remote control jobby that goes back and forth or connected to a snake in order to monitor the depth or how far we are and make sure the polymer doesn't travel to the inside of it as well. If polymer does infiltrate to the inside, we go ahead and remove all of it, obviously, because we need to promote the drainage that runs through there. And after those injections are performed, only after those injections are performed, to stabilize that lateral line, we can inject underneath the roadway in order to stabilize or densify everything between that lateral line and the underside of the roadway. Following that, a lift can generally be achieved, provided it's not an incredibly pliable surface at the top.
Okay, great. Next question was, it was talking about the restriction of the contamination. So the question is, how do you ensure that the groundwater migration is not does not occur with your injection process?
Good question, actually, and that's one of the cautions that I always give pretty much everyone about doing injections using a structural polyurethane. If I inject into the soil and I create sort of this impermeable barrier of structural polyurethane that water is not going to get through, and the water that I'm injecting into is displaced in the soil, you always have to take into consideration that it's going somewhere. And where is it that it's going? So oftentimes during the design phase, we might get multiple levels of injection to help influence the water to one direction or another. But it very much depends on the type of soil that you have, whether it's sand or clay or peat, silt, aggregate. What are you injecting into, as well as what you're injecting under, over, and around. So that's something you would need to consider during the design phase. But to give you an idea, if I wanted to control water going northward, I might inject eastward and westward, as well as underneath my injection level before providing my southward injections to push it all through.
One second, another question's coming in right now. Next question is, can you inject into water or areas with high flow?
Yes, you can. There's a couple of stipulations I have to that. The first is, depends on the product that you're using as far as structural polyurethanes are concerned. Unfortunately, because it is a newer industry and a lot of people are just now getting into it, I can't say that all products were created equal. A hydro-insensitive closed cell polymer injected into water will still react and become a rigid polymer provided excuse me, provided it's the right type of material to go in. An example of that, I recommend checking out a YouTube video. Just type in URETEK in water, and you'll find a comparison of URETEK and then a different structural polyurethane that was both injected into a 55-gallon trash can that was full of water. And the URETEK material was quite literally not affected at all. And there's a lot of videos out there of them shooting and restricting water flow into culverts or different things like that by injecting directly into the water. Even one cool one where they injected into trash bags to create trash bags in water in order to sort of limit the expansion and contain it into one area. So lots of cool things like that out there on YouTube. And then as far as the second part of that question, that was, can we inject into water? I'm sorry, I forgot the second part.
It was basically water, but it was talking about groundwater, presence of groundwater.
Oh, yeah, high pressure lines. That was the other half of that. So yes, we can inject into high pressure lines. The only exception to that is if we're talking about a pipe that's spraying water out, anything that's well over like 45, 60 psi just shooting water out. We have a general issue trying to plug that, and that's because it displaces the polymer before it has a chance to react. So even if you have a hyper-aggressive polymer, if you've got a high-pressure line that's leaking and displacing everything in there, then you'll generally have an issue trying to seal that. But leaking lines and even low or medium pressure lines, not a problem at all.
The next question was about material into the pipe. So when the material is injected into the pipe and material gets into the pipe, how do you remove the material?
Provided the pipe is at least 19 inches in diameter, you can generally just crawl in there and remove it. It's not super difficult to get out. Unless you let it cure for an extended period of time, then it gets very hard, in which case you would have to go in with shovels, roto hammers, or whatnot and actually pull it out. If it's a smaller diameter pipe, it may be able to be snaked out if it is hit at an early enough time, but you only have minutes is all I can say. You only have minutes to get that out. Other than that, it'll plug the pipe and you will have to replace a section of pipe. And that's why we say that experience is incredibly important when considering the use of structural polymer and which company you'll move forward with.
And I wanted to add on, I've heard of instances of utilizing Hydra Lansing for removing the material. Is that correct?
Mm-hmm. Yes, that's also correct.
Okay, well that was our last question. Unless anybody else has a question, if you want, we can hang around for a minute to take any remaining questions. For me, I'll just go ahead and re-emphasize that we'll be sending out an email following this this webinar, and it'll take you to a feedback form. If you need a PDH certificate or want access to the materials, just reply, go to the forum on our website, and it'll after you filled out the form, it'll take you to our materials, and additionally we'll be sending out an email in approximately a week time with anybody who requires a PDH certificate. I don't see any more questions there, Kyle. So, oh, we do have one more. I'm sorry. As follow up on the pressure pipe question, could you shut down a line and repair and restore at a normal pressure, maybe 80 psi? Would it create a watertight seal?
Yes, you can, but you run the risk of plugging the pipe with the polyurethane while the pressure's been shut off. And it's a high risk. But yes, you can. You create a water pressure seal or a pressure tight seal.
Okay, thank you for that question. And that appears to be it. So.
Perfect. Thank you, everybody, for attending the webinar. We always appreciate it, and we'll let you know when we're sending the next one out.
All right. Thank you, everyone. Have a great day.
Have a great day.